Assalamu alaikum. Ji, in today's lesson, I'm going to talk about abstract data types. Abstract data types we have already done in the class, and as you people were having some problems in solving the Q questions which I gave you in the sheet, so I decided that I can create a video on Q so that you will be able to grasp the ideas better in a better way, and then we will practice at least one or two questions so that I can assure you that you are able to understand the concept that how it works. Very easy concept. First of all, you need to know about what is meant by the term abstract data type. Abstract data type refers to any collection of data that you can operate on arrays. Like if I want to perform some operation over the arrays, I can add the value, I can remove the value in different ways. And the techniques which we are going to use include stacks, queue, and linked list. As we have discussed, that stack is a data structure that operates in last in first out manner. Now last in first out manner means the element which is inserted at the last will be removed first. Then we discussed about queues. Queue is a data structure just like queue for submitting bill, queue for buying something. So this queue refers to something which is something in linear order, right? So queue is a data structure that operates in first out manner. Now what does this first in first out manner tells us? That items that are added to the queue first will be removed first. In the same way, items which are inserted at the last will leave the queue at last. Very simple operation. And here you need to know few key terms that the process of inserting an element in the queue is known as in queue, while the process of removing an element from the queue is known as dequeue, right? So when we are going to insert an element, this is known as in queue, and the process of removing the element is known as dequeue. And the first item which will be inserted into the queue will be the one which will be removed out of the queue first, right? Now, one more thing here you need to know that there are two types of queues. One is linear queue and the other one is circular queue. You need to understand the code for both of these, but in your paper 2 you won't be asked about the like writing the code for in queue operation or writing the code for DQ operation. You only need to understand that how they works. So again, if you want to like write the definition in your notes, you can write that queue is a data structure. Queue is an abstract data type that can be used to represent the list of items in a way which are going to operate in first out manner, which means that the item which is added first will be removed from the queue first. The item which is inserted to the queue is removed at the last or at the end, you can say. Right now, moving onward, just wait for a second. So So now there are different queue operations which can be carried out. Now what are they? Management of files sent to the printer, buffers used with keyboards, and scheduling. So these are all the operations which can be carried out using queues. So queue operations, like what type of operations, what type of tasks can be carried out by the queue. Now basically in a queue we can carry out two operations, as I told you earlier that in queue is an operation in which a value can be inserted into queue, and the queue is an operation in which a value can be removed from the queue. So the value of the front pointer changes after dequeue, but the value of the rear pointer. Now what is the concept of front pointer and what is the concept of rear pointer? Front pointer is basically the top pointer, which is the initial one where in a queue data is pointed to. I will explain it to you. Let's say हमारे पास here. अच्छा जी. Yes. So just like we say that we have a queue outside the bank window. Let's say this is the bank window. People are, and the person who is submitting the bill is like this. ये वाला बंदा है. Okay. So what will happen? You people are standing in a queue. You want to submit your electricity bill, right? So now if I add locations over here, this is location 1, this is 2, then 3, then 4, then 5, then 6. Now this way there are 6 people standing. Now first person, let's say the first person who wants to submit the bill is Shiroz, right? Now Shiroz is currently pointing to front of the queue, if we can call it FOQ. So it means that at the front of the line, the first person who is standing is Shiroz. Now, behind Shiroz, we have, let's say, the other person is Ali. After that, third location pe we have Rohan. Then fourth location pe we have Khizr. At fifth location we have, let's say, Rafi. Now, sixth place is empty one. Now, what will be the front of queue pointing to? Front of queue will be pointing to the first element which is present in the queue, and that is referred by Shiroz. And what will be the end of queue pointing to? End of queue is pointing to location 5, which will be EOQ, right? Represented by EOQ. So you can say, now, if I want to add another person, इसको मैं front of queue पे add करूंगा or I'm going to add it to the end of the queue. I'm going to add it to the end of the queue. The reason is because it works in first out manner. Obviously, when Shiroz, Ali, Rohan, Khizar, Rafi, they all are waiting for the task to be completed अपने bill submission के लिए, they all are waiting. So the new person whom I'm going to add will be inserted at the sixth place, which means that if another person needs to be added, end of queue will be incremented by 1, and now it will be referred to location 6. Earlier it was at location 5, and when end of queue wants to insert another element, so it will be incremented by 1, so it will become E of q plus 1, right? So you need to remember that end pointer or end of queue is incremented by 1 whenever we want to insert an element. And when an item is removed, just like Shiroz got free after submitting his bill, तो शिरोज ने यहाँ से क्या हो जाना है, रिप्लेस हो जाना है. न्यू पर्सन इज गोइंग टू लाइक एड एट द लोकेशन 6, और शिरोज जो है उनका बिल सबमिट हो गया, वो चले गए हैं. Then what will happen when we want to remove something? Then front of queue will be incremented by 1. This is a very important concept. On the basis of these two concepts, the operations of the queue can be carried out. So again, I am repeating it. When we want to insert an element, add in an element known as in queue operation, we are going to do it at the rear part, and end of queue will be incremented by 1. And when an item needs to be removed from the queue, then we are going to increment f of q, that is front pointer, by 1. This is the basic principle on which you are going to carry out an operation. Now this was all about linear search. There is another queue operation that is included in your syllabus known as circular queue. And what happens in circular queue is that if the size of the, let me just explain you by doing the drawing part. Now I was talking about circular queue. In circular queue, basically we want to insert an element at a place when the end of queue is already full. Let's say we had these blocks. Last block was filled, second last was filled, third was filled, fourth was filled. but the place of the first block was free and we wanted to add another element into it. Now how circular queue operates? So basically this last pointer refers to end of queue. So what will happen in a circular queue? The last pointer or end of queue will be pointed to the first location. So this way we can insert an element, right? So this is how circular queue is going to operate. In a circular queue, if the vacant position, if the first position is vacant and is available, then you are going to point your end of queue to the that empty location which has been allocated to you. Okay, then I gave you a sheet in which you people were saying okay, there is some problem and you were unable to solve the queue operation. So let